In today's linear algebra video, we're going to be taking a look at how you can find the rank of a matrix. What we're going to do first is go over a little bit of background information behind the rank. Then I'm going to show you two different methods on calculating the rank. One involves either row echelon form or reduced row echelon form, and the other is going to be a manual kind of calculation based off of rows or columns. After that, we're going to jump into some Python programming. So a lot to cover today, and let's get started. All right, so let's talk a little bit about the rank of a matrix. So you'll often see the rank of a matrix written as like rank and then the matrix inside over here in parentheses. So the rank of a matrix is the maximum number of linearly independent rows or columns. And this will make a little bit more sense when we go through a few different examples a bit later. This also helps us with compression of data. A few things to know: a rectangular matrix is at most the rank of its smaller dimension. A square matrix can have a rank ranging from 0 to its size, and only a zero matrix has a rank of 0. And you can find the rank of a matrix through two different ways. First is if you have to have your matrix in RREF or REF, reduced row echelon form or row echelon form, and you'll look at the non-zero rows. And there's also manual calculation. We'll cover a little bit more on the next slide, but essentially, if we have the rank, it can help tell us if you have a unique solution, infinite solutions, or no solutions. And we're going to cover this a little bit later in this series. Well, actually, probably the next video in this series. All right, so how we can go through these two different ways of finding the rank of matrix. Method one, perform Gaussian elimination to find either REF or RREF and count the pivot columns, which is non-zero rows. Method two is manually check for column or row combinations. Add rows or multiply by scalar, automatically start with 1 for the first column or row. And if you have all zeros, it should say first column or row do not count. And for reduced row echelon form, just to let you know, I do have a video here on the channel already talking about this, so make sure to check out the linear algebra playlist. And anyways, the leading entry of a row is 1, or it can have all 0 rows, but has to be at the bottom. The leading 1 is called a pivot. It's to the right of the pivot from the row above. Each leading 1 is the only non-zero entry in its column. And these are some examples of row echelon form. Again, full video covering this, so I'm skipping by this a little bit faster, but I highly recommend you check out that other video. So let's find our first example over here. So we're going to perform Gaussian elimination to find RREF. So we have this matrix over here to the left, 2, 4, 8, 1, 2, 3, 4, 8, 10. I go through all the steps in my RREF video for this one, but it ends up being 1, 2, 0, 0, 0, 1, 0, 0, 0. Now, what I want to do is count the pivot columns, which is the non-zero rows. So up over here, we have 1, 2, 0. That counts as 1. Then we have 0, 0, 1. That also counts as 1. And then we have 0, 0, 0. Well, that's an all 0 row, so that will not count. So our rank is going to be 2. And our second example over here, we have 1, 0, 0, 4. We're good to go. We have 0, 1, 0, 3. Again, good to go. And then we have 0, 0, 1, 8. Right? And all three of these would count towards the rank. And example 3 over here, 1, 0, 2, 0. Good. 0, 1, 4, 0. Good. 0, 0, 1. Also good. And then lastly, we have all zeros. Well, that doesn't count. So we get a rank of 3. Now let's talk about how we can take a look at either the columns or rows. And we're going to start off with columns. So automatically, when we start off with this manual example, we're going to count this as 1, right? The only exception is if this would be 0, 0, 0. So we already know our rank is going to automatically be 1. And then we go into our second column over here. And we try to see if this second column can be created by any sort of combination of the previous columns. Well, you'll notice 4, 2, 8, and then we have 2, 1, 4. That's pretty easy, right? You multiply this by 2. 2 times 2 is 4. 1 times 2 is 2. 4 times 2 is 8. So this does not count, right? Because you could just have your first column here, multiply it by 2, then we have this. Now let's take a look at 8, 3, 10. Can we create 8, 3, 10 out of any combinations over here? Well, first thing I think of is like, okay, what if we multiply by 4? We would have 8, 4, 16. That doesn't work. How about we multiply this by 2, right? You would have 8, 4, 16. Again, doesn't work. Can we have a combination? Let's say we multiply this by 2 and add, right? You would have 8, and then you'd have 2 plus 2, 4. Nope, that doesn't work. And then 8 plus 8, 16. Nope. So We know from this example, right, from just off the columns, our rank is going to be 2. Now let's take a look at a little bit more of a complicated example, and we'll start off with this first column. Automatically, this will have 1, right, because it's not all zeros. Now let's take a look at column 2. Can we do anything to get into column 2? Well, we can multiply this by 2, but 4 times 2 is 8, 14. Nope, this is going to be linearly independent. So now we have automatically a rank of 2. How about this one over here, right? And 1 plus 2, maybe we have 3 over here. 4 plus 5, 9. That doesn't work. How about multiply by 3? 3, 12. Nope, that doesn't work. Okay, how about we multiply this by 1.5? Nope, 7.5. So again, linearly independent. We are good to go. All right, let's take a look at this one over here, 4th column. So this one over here is kind of interesting because you can multiply column 1 by 2 and then add in column 2. So you would see 2 plus 2 is 4. Okay, 8 plus 5 is 13, 14 plus 8, 22, 2, and then 1. Well, that's not linearly independent, right? You can create it from both column 1 and 2, so that doesn't count. How about this next one over here? Well, this is the same as column 2, right? 2, 2, 5, 5, 8, 8, 0, 0, 1, 1. Again, not linearly independent. And lastly, negative 3, negative 6, negative 9, negative 1, and 0. Well, if you multiply this by negative 1, you get that same results in that column. So we have 3 independent columns and then 3 that are not. So our final rank for this example over here is going to be 3. All right, so let's take a look at rows this time. So row 1 we have over here is 2, 6, 8 because it's not triple zeros. We're good to count this as 1, right? Then we go to the second row, 3, 4, 7. Well, you can multiply 2 by 1.5, but that won't work for 6 because we would have 9 over there. So now we have a rank of 2. And lastly, we look at 4, 12, and 16. Well, if you double row 1, 2 times 2 is 4, 6 times 2 is 12, 8 times 2 is 16. So that does not count. And our rank is going to be 2. Now let's take a look at this example over here. Well, it's our first row, 1, 1, 0, 0, 0. So good to count that. Then we jump down over here. Nothing we could do for our first row would get that. We're good as well. Then we have our third row over here. Again, nothing we could do would be able to get this one over here. And then we take a look at row 4. And that's the same as 1, so it doesn't count. Row 5 is the same as 2, so that does not count. And lastly, we have 1, 1, 1, 1, 1. Well, at first you might think we wouldn't be able to get this combo, but if you take a look, if we add rows 1, 2, and 3, right, we'd have 1s through here, and then we add in our last one, and that could be created from other rows. So our rank is going to be 3 because these are the only unique rows, and everything else down here has been already represented above or can be created. So with these examples out of the way, I think we are ready to code in Python. So make sure you grab your notebook and let's start going through the code. All right, let's get going. And we'll need 2 things for this video. So first is going to be NumPy. So import NumPy as NP. And if you've been watching this video series, almost every single video has used NumPy. And next we'll need SymPy. And I think that's how you pronounce it. From SymPy, import in matrix. So like that. And we're off to the races. So first example is going to be our RREF example. This is going to emulate what we just covered in the slides. So we'll say RREF example. What I'm going to show you though on here is calculating the matrix rank before the matrix is moved into RREF, and then after, just to show you, it's going to be the same. So let's do this. First, we're going to define a matrix. So we're going to define matrix pre-RREF equals np.array. And we're going to do the 3 by 3. Again, it's going to cover exactly what we did in the video. So 3 by 3 over here. And we'll start off with is 2, 4, 8. So 2, 4, and 8. Then we'll jump to the next row and we'll have 1, 2, 3. So we'll have 1, 2, and 3. And then lastly, we'll have 4, 8, 10. So 4, 8, and also 10. We have that over here. And okay, awesome. Now, what we're going to do is we're going to calculate the rank. So what we'll have over here is rank underscore, and I'm just going to paste in the same name that we had above. I'm not going to type it again. And we're going to say np.linalg for linear algebra, right? And then we're going to do dot matrix rank like that. And then just pass in our matrix. So matrix pre-RREF, we have that over here. And if I remember correctly, this was 2. Well, it should be 2 because we already covered this side of things, right? 2, 4, 8 turns to 4, 8, 10. But we'll print this out regardless, and you'll see it comes out as 2. So awesome. Now what we're going to do is we'll say SymPy matrix pre-RREF, and we're going to have to convert this. So it's matrix, and then pass in our matrix, which is right over here. I haven't recorded my video on RREF or REF yet, but I'll be covering that in here. And then we'll have a matrix post RREF equals, and we have our SymPy matrix here. And then we'll just say .RREF, right? Okay. Again, reduced row echelon form, but it is a tongue to say that, so I'd rather just say RREF. Then we'll have RREF matrix, so RREF matrix equals matrix post RREF 0. All right. And then lastly, we'll have NumPy RREF matrix, because we're going to convert it back to NumPy, equals np.array, and then pass in our RREF matrix, and then dtype equals floats. And then lastly, what we're going to do is print out this NumPy matrix just to show you it looks like. So this is the 1, 2, 0, 0, 0, 1, 0, 0, 0. Again, if we look at this over here, triple zeros at the bottom, we won't count that, but we have 2, right? 2 rows that have numbers in them, so we have 2 in general. But if we wanted to get the rank, what we're going to do is say rank and of matrix, that NumPy RREF matrix equals np.linalg, then we'll do matrix rank, and then just pass in our NumPy RREF matrix. And lastly, we'll print this out. And we get the final answer being 2. So a lot of steps here. Again, convert into RREF, and then what we do after is go back into NumPy array, and then we calculate our matrix rank. And you'll see, again, it is the same for both 2 and 2. So now what I want to do is kind of go through these examples of the manual calculations. So we'll go through example 2. Well, actually, I did another RREF. So example 2 RREF. And this time what we'll do is RREF example 2 equals np.array. This has already been transformed, so you don't have to worry too much about it. And in over here, we'll have first is 1, 0, 0, and 4. Like that. Space it out. Okay. Then on our next line over here, we'll have 0, 1, 0, 3. And then lastly, what we have is 0, 0, 1, 8. So 0, 0, 1, and 8, like that. And we'll just print this out just to show you this is working correctly. Great. Exactly what we had in the video. And then literally just one line of code. So we'll have RREF example 2 rank equals np.linalg.matrix rank, and then pass in our example 2 over here. And if we print that out, get the value of 3. Great. And if we take a look at example 3 this time, this is going to be a lot of the same stuff, but anyways, example 3. And what I'll do to save you guys a little time is I'll just paste in the matrix over here, 1, 0, 2, 0, 0, 1, 4, 0, 0, 0, 1, and 4 zeros at the very bottom. We'll just copy this code. It's going to essentially be the same. Change this to 3 over here. 3. Let's just print out this. Right. And you'll see we get a value of 3 over here. So awesome. We know this is working. And now what I want to do is go over our manual examples. So manual calculation examples. All right. So now what we're going to do is take a look at some column examples for the manual calc. First one we've already done, right? So if we go back over here, or is that this 214, 428, 8310, right? You just multiply this by 4 and 3, 2, 1. All right, so our first column example we already covered, right? Where we just multiply this by 2. So I'm not going to do that again down over here. Instead, we'll take a look at a little bit more complicated example. And I'm just going to paste in our code over here. So column example 2, we have 1, 2, 3, 4, 2, negative 3, right? 4, 5, 6, 13, 5, negative 6, 7, 8, 9, 22, 8, negative 9, 1, 0, 1, 2, 0, negative 1, 0, 1, 0, 1, 1, 0. So we'll use that. And then there, again, the same exact code. This over here. And then just change this out. So, whoops, accidentally created that. Delete that again. Paste in our column example. And then print. And we're just trying to confirm what we had in the slides. We got 3 there. Awesome. And then let's just take a look really quick at our 2 row examples. So we'll look at our row examples. Right. Our first row example over here is pretty basic, right? 2, 6, 8, 3, 4, 7, 4, 12, 16. Again, we just multiplied this first row by 2. We'll just grab code, define the rank, change this out, and then just print it. So print row example 1 rank. We get 2. And lastly, our little bit more of a complicated example. We'll grab that here in a second. So we have this over here. For example 2. And then grab this code, change it for 2 on each of these. And I'll print this out. I know this is a lot of repetition, but well, you'll get this ingrained. And also, secondly, I wanted to cover what we did in the slides, right? And you can see that we get the final value of 3. So finding the rank with Python is super easy. You don't necessarily need to convert your matrix into REF or RREF, right? NumPy has this over here, matrix rank. And all you have to do is define your matrix a little bit earlier, then pass in your matrix over here as a parameter, call it, and you'll get your rank like super easily. But again, I just wanted to show you guys that, you know, you can convert your matrix into RREF. It's going to be the same value. It doesn't really matter too much. And yeah, we confirmed all the different examples in the slides. All those ranks were correct. And that's essentially the video. Hope you guys enjoyed this video on the rank of a matrix. And if you learned something new, make sure to subscribe to the channel. We're uploading 3 to 4 different data science focused videos every single week. And if you want to continue learning linear algebra, I have a few videos linked down below in the description and a playlist that you can click on right over here.